Hey there, and welcome. If you're listening in, maybe on your commute, maybe while getting some things done, we really want to make this time count for you, especially if you're in the health, safety, or environment field.
Right. Today, we're kind of laying the groundwork, looking at the basics of workplace safety.
Exactly. Building that solid foundation that, really supports all the important work that you do day to day.
We're going to try and connect the dots, basically. How do we get from a law passed in Congress all the way down to specific rules and the hands-on science of industrial hygiene that actually keeps people safe?
Yeah, we want to unpack how those standards get made and really shine a light on industrial hygiene's role in, making them work in the real world. We've looked at a lot of material, the laws, the regulations, IH practices, some key examples.
And there are some interesting links, maybe even a few things that'll make you think, okay, that's how that fits together. It's all about gaining that clarity.
Hopefully, yeah. A fresh look at this field. So, should we jump in?
Absolutely. Let's start at the top. How does an idea, maybe a concern about safety, become an actual law that affects everyone? It usually starts with Congress.
Right. So walk us through that. We hear about bills becoming laws, but what are the actual steps?
Okay, so it's basically three main stages. First, you need someone to actually propose it. A member of the House or the Senate has to introduce a bill. That's the formal starting point.
And where do these ideas for bills even come from? Incidents? Research?
All of the above, really. Could be a major incident that highlights a gap, new scientific understanding, maybe pressure from industry or safety groups, lots of sources.
Okay, so step one, proposal. What's next?
Then it's got to get through Congress itself. That means both the House and the Senate need to debate it, maybe change it a bit, and ultimately approve it. A majority vote in both chambers.
Yeah, it sounds like it could get complicated, getting both sides to agree on the exact same thing.
Oh, it definitely can. Lots of negotiation, amendments back and forth. But assuming they do agree on the same final version, it goes to the president. Stage 2.
The moment of truth. Sign or veto.
Pretty much. If the president signs it, boom, it's law. If they veto it, well, Congress gets another shot. They can override the veto, but it takes a big majority, 2/3 in both the House and Senate.
Okay. And once it is officially a law, where does it live? How do people find it?
It gets published in what's called the United States Code, the USC. Think of that as the big official library of all the federal laws that are currently active.
Got it. So the law sets the big picture, the main requirement, but those laws can be pretty general, right? How do they turn into specific rules for, say, a chemical plant?
That's exactly the next step. The laws themselves often give authority, the power, to government agencies, like the EPA, Environmental Protection Agency, or OSHA, the Occupational Safety and Health Administration.
Ah, right. So Congress says, make workplaces safe, and then tells an agency like OSHA, okay, you figure out the specifics.
Precisely. The law gives the mandate, maybe the broad goals, and the agency gets the job of creating the detailed regulations to actually make it happen. They define how to comply.
So how does an agency, let's stick with OSHA, actually make a regulation? Is it just decided internally?
No, there's a process for that too, usually in two main steps. First, OSHA identifies a need. Maybe new data shows a rise in a certain type of injury or technology changes, or someone petitions them. They decide, okay, we need a rule here. Then they draft a proposed regulation.
Proposed, meaning it's not set in stone yet. People get to weigh in.
Exactly. That's crucial. They publish this proposed rule in the Federal Register, the FR. You can think of the FR as the government's daily newspaper for rules and notices.
So anyone can see it. Businesses, workers.
Yep. Publication in the FR starts a public comment period. Anyone affected, companies, unions, safety professionals, the public can read the proposal and send in their thoughts, their data, their concerns, maybe suggest changes.
Okay, that sounds fair. Allows for real-world input. What happens after they get all that feedback?
The agency has to review all those comments. Seriously consider them. Based on that feedback, they might revise the proposed rule, sometimes significantly.
Yeah.
Then, the final version of the regulation gets published, again in the Federal Register. That makes it official. But for practical use, it's also codified, meaning it's organized and put into the Code of Federal Regulations, the CFR.
The CFR. That's the big book of all the final rules from all the agencies, organized by subject.
You got it. It's the comprehensive collection. And for anyone in our field, it's super important to know that OSHA's regulations are specifically found in Title 29 of the CFR.
Title 29. Definitely need to remember that one.
Yeah.
So just to summarize that bit, laws give the what and the authority. Regulations give the detailed how.
That's a great way to put it. Laws set the requirement. Regulations provide the specific standards, procedures, and compliance details.
Okay, that connection is much clearer now. So we have these regulations. How do we actually make sure they're being followed and that workplaces are safe day to day? This feels like where industrial hygiene really steps in.
Absolutely. This is where the science meets the shop floor, so to speak. Industrial hygiene is all about anticipating potential health hazards in the workplace, then recognizing them if they're there, evaluating how serious they are, and finally, controlling them.
Anticipate, recognize, evaluate, control. AREC. The core principles.
Exactly. Think of industrial hygienists as the health detectives for the workplace. Their whole focus is preventing people from getting sick or injured because of their job.
Health detectives. I like that. So break down those phases for us. What does identification or recognition really involve?
It starts with understanding. You need to really know the processes, what materials are being used, chemicals, solvents, metals, what tasks people are doing, the physical environment. Is it noisy, hot? Are there vibrations?
So a deep dive into the actual work being done.
Right. And anticipating means using experience and knowledge to think, okay, with this process, what hazards are likely? Like if there's welding, you immediately think fumes, UV light. If there's painting, you think solvents, maybe vapors.
So you're looking for chemicals, dust, noise, heat, radiation, a whole range of
things. A very wide range. And once you've identified potential hazards, the next step is crucial, the evaluation. You need to figure out how much exposure is actually happening. Is it a little bit or a lot? Is it above safe limits?
Right. Just knowing it's there isn't enough. You need to measure the risk. How's that done?
This is where the tools come out. Industrial hygienists use monitoring air sampling pumps with collection media, noise dosimeters, heat stress monitors, light meters, radiation detectors, all sorts of instruments.
To get actual numbers, actual data on exposure levels.
Exactly. We need to quantify it. A key concept here is the time-weighted average, or TWA. We don't just measure for 5 minutes. We want to know the average exposure over a full shift, usually 8 hours, because levels can go up and down.
Ah, okay. So the TWA gives you that overall picture for the workday.
Correct. It accounts for peaks and valleys in exposure. And once you have that evaluation data, you compare it to established occupational exposure limits, OELs, to see if there's a problem.
And if the evaluation shows exposure is too high.
Then we move to the third phase, control. This is the problem-solving part. How do we reduce or eliminate the exposure?
Okay, what kinds of controls are typically used?
We use what's called the hierarchy of controls. It prioritizes the most effective methods first. At the top is elimination or substitution, getting rid of the hazard completely, or replacing it with something safer, if that's not possible.
Then you move down a list.
Right. Next come engineering controls. These are physical changes to the workplace to reduce the hazard at the source. Think ventilation systems like local exhaust ventilation, LEV that sucks fumes away right where they're made, or enclosing a noisy machine.
So changing the work environment itself. What if engineering controls aren't enough or aren't feasible?
Then you look at administrative controls. These change how people work. Things like rotating workers out of noisy areas, changing work schedules to limit exposure time, establishing safe work procedures.
Okay, modifying work practices. Yep. And the last resort.
The last line of defense is personal protective equipment, PPE. Things like respirators, gloves, safety glasses, hearing protection.
But that's really only used when other controls can't bring exposure down to safe levels, right? Because it relies on the worker using it correctly every single time.
Exactly. PPE is essential in many cases, but it has limitations. Respirators, for example, need to be the right type for the hazard. They have to fit properly, which means fit testing, and people need training on how to use and maintain them. It protects the individual, but doesn't remove the hazard itself.
That hierarchy makes a lot of sense. Prioritize fixing the source first. So industrial hygienists do way more than just take measurements.
Oh, absolutely. They collaborate with safety teams, engineers, management workers. They need strong analytical skills. They interpret data. They develop control strategies, often using info from things like safety data sheets, SDSs, which we should definitely talk more about. And yeah, they help ensure the company is meeting those OSHA regulations we discussed.
They really are the bridge between the rules and the reality of keeping people healthy at work.
Okay, we've mentioned OSHA and EPA quite a bit. Let's zoom in on them. Start with OSHA, Occupational Safety and Health Administration.
Okay, so OSHA came into being because of the Occupational Safety and Health Act of 1970, the OSHA Act. Its core mission is pretty clear. ensure safe and healthful working conditions for employees, they set and enforce standards. And the OSHA Act itself placed a big responsibility directly on employers, didn't it?
Hugely significant. The Act has what's called the General Duty Clause. It basically says every employer must provide a workplace free from recognized hazards that are causing or likely to cause death or serious physical harm. That's a fundamental obligation.
So it's not just about following specific rules, but also this general responsibility for safety. And OSHA has the teeth to enforce this.
They do. OSHA develops detailed regulations, conducts workplace inspections usually unannounced, and if they find violations, they can issue citations and propose penalties, which can be substantial fines.
And those specific regulations are all in Title 29 of the CFR, as you mentioned. Can you give some examples of major OSHA standards people might encounter?
Sure. We touched on the Respiratory Protection Standard, 1910.134. A really big one, especially in chemical industries or manufacturing, is the Process Safety Management Standard, PSM, 1910.119, for handling highly hazardous chemicals. We absolutely need to talk more about PSM.
Okay, definitely. What else?
There's also the Hazard Communication Standard, or HAZCOM, 1910.1200. That's the one that mandates things like chemical labels and the safety data sheets, ensuring workers have the right to know about the hazards they work with.
Right, the SDS connection again. And during an inspection, what can OSHA officers do?
They have the right to enter the workplace, inspect conditions, look at records related to safety and health, and also, importantly, talk privately with employees about their concerns. And yes, issue citations if they find violations. Employers can contest these citations, of course.
Okay, so OSHA employee safety within the workplace. What about the EPA, the Environmental Protection Agency? How do they fit in?
EPA has a much broader scope. Their job is protecting human health and the environment overall. They look beyond the factory fence line, you could say.
So not just worker safety, but public health and the ecosystem.
Exactly. EPA sets limits on pollution released into the air, water, and land. They regulate hazardous waste disposal. They can impose big penalties if companies release more toxic chemicals than permitted.
So while not directly focused on the worker inside, EPA rules can definitely influence how companies manage chemicals and processes, which might indirectly improve worker safety too.
Absolutely. And there's a key area of overlap or perhaps parallel regulation with OSHA. You mentioned PSM for OSHA. Well, EPA has something similar called the Risk Management Program Rule, or RMP.
RMP. Okay, how is that different from PSM?
Both deal with preventing accidental releases of hazardous chemicals. But the big difference is focus. PSM is primarily focused on preventing harm to employees on site. RMP puts a much stronger emphasis on preventing harm to the public and the environment off-site.
So RMP looks at the potential consequences outside the facility boundaries.
That's the key distinction. RMP requires facilities with certain amounts of highly hazardous substances to assess the potential off-site consequences of a worst-case release, develop prevention programs, and have a robust emergency response plan that includes coordinating with local responders and notifying the public if necessary.
So they have to submit this plan to the EPA?
Yes, they develop a risk management plan document and submit it to EPA. It includes the hazard assessment, the prevention program details, and the emergency response plan. It's about managing the risk to the surrounding community.
Okay, so OSHA is inward-looking, employee-focused via PSM. EPA is outward-looking, community and environment-focused via RMP. They tackle similar hazards, but from different angles with different primary concerns.
You've nailed it. Different mandates stemming from different founding legislation, OSHA Act for OSHA, various environmental laws for EPA.
Right, let's circle back to PSM then. You said it's critical for managing highly hazardous chemicals. It sounds pretty comprehensive.
Yeah.
What are the main parts of an OSHA PSM system?
It is comprehensive. There are 14 distinct elements required. It really starts with having good process safety information. You need detailed info on the chemical hazards, the process technology, and the equipment used. What are the dangers? How does it work? What are the limits?
Foundation first. Makes sense. What's element 2?
Process hazard analysis, or PHA. This is huge. It's a systematic effort to identify what can go wrong, scenarios that can lead to a release. You evaluate how likely they are, how bad they could be, and what safeguards are needed. It's proactive hazard hunting.
Thinking through the risks before they happen.
Okay. Third is operating procedures. Clear written instructions for every phase. Startup, normal operation, shutdown, emergency shutdown. Operators need these readily available.
The how-to manual for running things safely.
Pretty much. Then number 4 is employee participation. PSM requires actively involving employees in developing and running the PSM program. They often know the process best.
Good point. Their input is vital. What about making sure they can do the job safely?
That's training, element 5. Initial training for anyone involved in the process, covering hazards and procedures, and regular refresher training, too.
Keeps knowledge fresh. What about outside workers coming in?
Element 6, contractors. You need procedures to ensure contractors know the hazards, follow safety rules, and their safety performance is evaluated. Everyone on site needs to be safe.
Right. And before firing up a new process or making a big change.
Element 7, pre-startup safety review, or PSSR. A final check before introducing hazards. Confirm safety features are installed, procedures are ready, training's done, like a final gonna-go safety check.
Makes sense. What about keeping the equipment itself reliable?
Element 8, mechanical integrity. Procedures for ensuring equipment is designed, installed, maintained, inspected, and tested properly to prevent failures, like pumps, vessels, piping.
Keeping the hardware sound. What about things like welding near flammable materials?
That's covered by Element 9, hot work permits, a system to control ignition sources. Requires authorization before starting any spark-producing work near hazards.
Essential. And processes aren't static, things change.
Which brings us to Element 10, management of change, or MOC. Any change equipment, chemicals, procedures, even staffing sometimes needs formal review and approval before it happens to make sure it doesn't create new, unmanaged risks.
So you don't accidentally introduce a new hazard. What if something does go wrong?
Element 11, incident investigation. A requirement to investigate incidents and near misses to find the root causes, not just blame, and implement changes to prevent recurrence. Learning from mistakes.
Crucial for improvement and being ready for the worst.
Element 12, emergency planning and response. Having clear plans for what to do if there is a release or other emergency, evacuation, shutdown, first aid.
How do you know the whole system is working?
Element 13, compliance audits. Regular checks at least every 3 years to verify the whole PSM system is implemented and functioning as intended. An internal checkup.
And finally, what about confidential process info?
Element 14, trade secrets. Allows companies to protect proprietary information, but still requires them to provide necessary hazard info to employees and others who need it for safety. A balancing act.
Wow, 14 elements. That's a very thorough system for managing major chemical hazards. You also mentioned safety data sheets, SDSs, several times. Let's focus on those. Why are they so critical?
The SDS, or MSDS as it used to be called, is really the cornerstone for understanding chemical hazards. Its main job is to tell you about the substance's properties, physical, chemical, toxicological, so you can figure out the potential hazards. It's absolutely vital for that identification phase in industrial hygiene.
So it's the go-to document for basic safety info on any chemical.
Absolutely. If you're going to work with or around a chemical, the SDS is where you start. It gives you the essential data you need to handle it safely.
What kind of information is actually in an SDS? Is it standardized?
Yes. Thankfully, it's now standardized globally into a 16-section format. You'll find the chemical identity, hazard identification, composition, first aid measures, firefighting measures, accidental release measures, handling, and storage.
Okay, so pretty comprehensive.
Very. It also covers exposure controls and personal protection, like what ventilation is needed, what kind of gloves or respirator might be required, plus physical and chemical properties, stability and reactivity, toxicological information, ecological info, disposal, transport, regulatory info. It's packed.
So it directly informs how you develop those control strategies we talked about. Ventilation, PPE choices.
Directly. You use the SDS information to understand the risks and select the right controls. It tells you what you're dealing with and gives guidance on how to manage it.
And where do you get these SDSs from?
The primary source is the manufacturer or supplier of the chemical. They're required by OSHA's HAZCOM standard to provide an SDS for any hazardous chemical they sell or distribute.
And employers have to make sure workers can access them.
Yes, employers must maintain a collection of SDSs for all hazardous chemicals in their workplace and ensure they are readily accessible to employees during their work shifts. Could be binders, could be electronic databases, but they have to be available.
Got it. Okay, we've covered laws, Regulations, industrial hygiene, specific programs like PSM, and tools like SDSs. Let's pull this together from the employer's perspective. What's the bottom line for them in ensuring a safe workplace?
Well, fundamentally, as we said, the OSHA Act puts that responsibility squarely on the employer. It's their legal duty to provide a safe place to work.
It's the law. So how do they meet that duty in practical terms?
First off, compliance. They have to follow the specific OSHA regulations that apply to their operations. That means knowing the rules, implementing the required programs, being ready for inspections, and understanding the consequences of not complying citations, fines.
Okay, follow the rules. But safety is more than just compliance, right? It's about preventing incidents.
Absolutely. Proactive hazard identification and evaluation is key. Employers need systems to actively look for hazards, chemical, physical, biological, ergonomic, and then assess the risks using tools like PHAs, job hazard analyses, and information from SDSs.
Find the dangers before they cause harm, and once found,
Implement controls. Put measures in place to eliminate or reduce the risks following that hierarchy we discussed. Prioritize engineering controls, ventilation, enclosures, machine guards. Then administrative controls, safe work procedures, training, job rotation. And finally, ensure proper PPE is provided and used correctly when needed, especially things like a full respiratory protection program if respirators are required.
engineering, administrative, PPE.
Got it.
What about the workforce itself?
Employee participation and training are non-negotiable. Workers need to know the hazards, understand the safe procedures, and be trained on how to use equipment safely. And involving them in safety committees or hazard identification processes makes the whole system stronger. They see things management might miss.
And safety isn't a set-it-and-forget-it thing, is it?
Definitely not. Employers need to be constantly maintaining and reviewing safety procedures, updating PHAs, managing changes effectively through MOC, reviewing operating procedures, ensuring training is current. It's a continuous cycle.
What about when things do go wrong, even with good systems?
Then incident investigation comes in. A thorough investigation to find root causes, not just immediate causes, and implementing corrective actions to prevent it from happening again. Learning from every event, even near misses.
So it really is that continuous loop. Identify, evaluate, control, and then review and improve. Always striving to get better.
That's the essence of a strong safety management system.
Okay, let's try and make this even more concrete. Can we look at some practical examples of industrial hygiene evaluation and control, maybe drawing on some of that specific IH material?
Sure. Thinking about identification first, that material really emphasizes the variety of hazards. Not just chemicals, but noise, radiation, heat, cold, vibration, ergonomic stresses. And it stresses thinking about how things get into the body. Breathing them in, inhalation, absorbing through the skin, swallowing them, ingestion, or even through cuts, injection.
All those different routes of entry matter for control. Okay, how about evaluation examples? You mentioned TWA.
Right. The time-weighted average calculation is fundamental for air contaminants. The material likely shows the formula, but the concept is key for listeners. You measure concentration over different times, multiply concentration by time for each period, add those up, and divide by the total time, usually 8 hours. It gives that average exposure level.
And you compare that TWA to an OEL, an occupational exposure limit, to see if it's acceptable.
Exactly. And it gets more complex with mixtures. If you're exposed to 2 solvents, for instance, even if each one alone is below its limit, the combined effect might be too much. There are formulas, like the one for TLV-TWA mixtures, that help assess that combined exposure against the limits in the mixture. You basically see if the sum of the fractions of each exposure limit is greater than 1.
So you can't just look at chemicals one by one if multiple are present. Good point. What about noise evaluation?
Noise is measured in decibels, dB. But evaluation isn't just about how loud it is, it's about loudness and duration. OSHA has a table showing permissible noise exposures you can be exposed to, say, 90 dBA for 8 hours. But if the noise goes up to 100 dBA, the allowed time drops significantly, maybe only 2 hours. Louder means less time allowed.
That makes sense. Protects against hearing damage over time. What about controlling vapors with ventilation? Any practical examples there?
The material likely touches on estimating ventilation needs. Conceptually, like using figure 3.3 perhaps, it shows that if you have something evaporating quickly or if you need to get the concentration really low, you need more airflow, more ventilation, compared to something evaporating slowly or where a slightly higher concentration is acceptable.
More hazard, more ventilation needed.
Yeah.
Simple concept. And the types of ventilation.
It reinforces the 2 main types. Dilution ventilation just brings in fresh air to mix with and lower the overall concentration in the room.
Okay, for less toxic things, maybe. But local exhaust ventilation, LEV, is usually better. It captures the contaminant right where it's generated. Think of a fume hood in a lab or an exhaust duct right over a welding point, like maybe shown in figures 3.6, 3.7, 3.8 concepts.
Yeah.
It removes the hazard before it spreads.
Capture at the source, that sounds much more effective for toxic stuff. Generally, yes. It often requires less air volume overall than dilution too. And again, the material would emphasize that hierarchy. Engineering controls like LEV first, then administrative practices, and PPE like respirators, maybe referencing tables like 311 showing different types, or gloves and glasses like in table 310 as the last resort.
So those examples really show the practical application, measure the problem, evaluate, then implement the right fix, control, always aiming for the most effective solution high up on that hierarchy.
Exactly. It connects the dots from the regulations and principles down to the actual hardware and procedures used on the job.
Well, this has been incredibly insightful. We've really covered the spectrum, haven't we? From how laws get made to the nitty-gritty regulations, and then how industrial hygiene brings it all to life in the workplace.
Yeah, seeing the connections is key. The law provides the authority, the regulations set the specific requirements, and industrial hygiene provides the knowledge and the methods, the science, to actually meet those requirements and protect people.
And for you listening, especially if you're an HSE professional, using maybe your commute time to stay sharp, we really hope this discussion helps clarify those foundations. Understanding why things are done the way they are makes you much more effective.
Absolutely. Having that solid grasp of the fundamentals, the laws, the regs, the IH principles really empowers you to make better decisions, implement better controls, and ultimately contribute to a safer, healthier work environment for everyone you work with.
So maybe as you go through your workday, think about these connections. How does the specific regulation you deal with trace back to a law? How are industrial hygiene principles being applied? Or maybe how could they be applied better? Perhaps ask yourself, what's one rule or practice in my field that I see a bit differently now?
That's a great way to think about it. It's all part of that continuous learning and improvement that's so vital in safety.